3.5 got the PEP 484 type hints. What is type hinting, and is it used by the interpreter, the hints, or is it just syntactic sugar?
So the type hints is an optional mechanism that people can use, and it's especially popular with sort of larger companies that have very large code bases written in Python.
Do you think of it as almost like documentation saying these two variables are this type?
More than documentation. I mean, so it is a sublanguage of Python where you can express the types of variables. So here's a variable and it's an integer. And here's an argument to this function and it's a string. And here is a function that returns a list of strings.
But that's not checked when you run the code.
But exactly. There is a separate piece of software called a static type checker that reads all your source code without executing it and thinks long and hard about what it looks from just reading the code that code might be doing and double checks if that makes sense if you take the types as annotated into account.
So this is something you're supposed to run as you develop.
It's like a linter. Yeah, that's definitely a development tool, but the type annotations currently are not used for speeding up the interpreter. And there are a number of reasons. Many people don't use them. Even when they do use them, they sometimes contain lies where the static type checker says everything's fine. I cannot prove that this integer is ever not an integer, but at runtime somehow someone manages to violate that assumption. And the interpreter ends up doing just fine. If we started enforcing type annotations in Python, many Python programs would no longer work. Mm-hmm. And some Python programs wouldn't even be possible because they're too dynamic. And so we made a choice of not using the annotations. There is a possible future where eventually 3, 4, 5 releases in the future, we could start using those annotations to sort of provide hints, because we can still say, well, the source code leads us to believe that these x and y are both integers, and so we can generate an add integer instruction. Mm-hmm. But we can still have a fallback that says, oh, if somehow the code at runtime provided something else, maybe it provided 2 decimal numbers, we can still use that generic add operation as a fallback. But we're not there.
Is there currently a mechanism, or do you see something like that, where you can almost add like an assert inside a function that says, please check that my type hints are actually mapping to reality? Sort of like insert manual static typing.
There are third-party libraries that are in that business.
So it's possible to do that kind of thing? It's possible for a third-party library to take a hint and enforce it? It seems like a tricky thing.
What we actually do is, and this, I think this is a fairly unique feature in Python, the type hints can be introspected at runtime. So while the program is running, I mean, Python is a very introspectable language. You can look at a variable and ask yourself, what is the type of this variable? And if that variable happens to refer to a function, you can ask, what are the arguments to the function? And nowadays, you can also ask, what are the type annotations for the function?
So the type annotations are there inside the variable as it's at runtime.
They're mostly associated with the function object, not with each individual variable, but
right.
You can sort of map from the arguments to the variables.
And that's what a third-party library can help.
Exactly. With. And the problem with that is that all that extra runtime type checking is going to slow your code down instead of speed it up.
I think to reference this sales pitchy blog post that says 75% of developers' time is spent on debugging, I would say that in some cases that might be okay. it might be okay to pay the cost of performance for the catching of the type errors.
And in most cases, doing it statically before you ship your code to production is more efficient than doing it at runtime piecemeal.
Yeah. Can you tell me about MyPi project? What is it? What's the mission? And in general, what is the future of static typing in Python?
Well, so MyPi was started by a Finnish developer, Jukka Lehtusalo.
So many cool things out of Finland, I gotta say. Just that part of the world.
I guess people have nothing better to do in those long, cold winters.
Yeah.
I don't know. I think Jukka lived in England when he invented that stuff, actually. But MyPi is the original static type checker for Python. And the type annotations that were introduced with PEP 484 were sort of developed together with the static type checker. And in fact, Jukka had first invented a different syntax that wasn't quite compatible with Python. And Jukka and I sort of met at a Python conference I think in 2013. And we sort of came up with a compromise syntax that would not require any changes to Python, and that would let MyPi sort of be an add-on static type checker for Python.
Just out of curiosity, was it like double colon or something? What was he proposing that would break Python?
I think he was using Angular brackets for types like in C++ or Java generics.
Yeah, you can't use Angular brackets in Python. It would be too tricky for template.
Well, the key thing is that we already had a syntax for annotations. We just didn't know what to use them for yet. So type annotations were just the sort of most logical thing to use that existing dummy syntax for. So, but there was no syntax for defining generics directly syntactically in the language. MyPi literally meant my version of Python, where it refers to Jukka. He had a parser that translated MyPi into Python by like doing the type checks and then removing the annotations and all the Angular brackets from the positions where he was using them. Boy. But a preprocessor model doesn't work very well with the typical workflow of Python development projects.
Yeah, it's funny. I mean, that could have been another major split if it became successful. Like if you watch TypeScript versus JavaScript, there's like a split in the community over types, right? That seems to be stabilizing now.
It's not necessarily a split. There are certainly plenty of people who don't use TypeScript, but just use the original JavaScript notation, just like there are many people in the Python world who don't use type annotations and don't use static type checkers.
No, I know, but there is a bit of a split between TypeScript and old school JavaScript, ES, whatever.
Well, in the JavaScript world, transpilers are sort of the standard way of working anyway, which is why TypeScript being a transpiler itself is not a big deal.
And transpilers, for people who don't know, it's exactly the thing you said with MyPi. It's the code, I guess you call it pre-processing, code that translates from one language to the other. And that's part of the culture, part of the workflow of the JavaScript community. So
that's right. At the same time, an interesting development in the JavaScript/TypeScript world at the moment is that there is a proposal under consideration. It's only a stage 1 proposal that proposes to add a feature to JavaScript where, just like Python, it will ignore certain syntax when running the JavaScript code. And what it ignores is more or less a superset of the TypeScript annotation syntax.
Interesting.
And so that would mean that eventually, if you wanted to, you could take TypeScript, and you could shove it directly into a JavaScript interpreter without transpilation. The interesting thing in the JavaScript world, at least the web browser world, the web browsers have changed how they deploy, and they sort of update their JavaScript engines much more quickly than they used to in the early days. And so there's much less of a need for transpilation in JavaScript itself, because most browsers just support the most recent version of ECMAScript.
Just on a tangent of a tangent, do you see, if you were to recommend somebody use a thing, would you recommend TypeScript or JavaScript?
I would recommend TypeScript.
Just because of the strictness of the typing.
It's an enormously helpful extra tool that helps you sort of keep your head straight about what your code is actually doing. I mean, it helps with editing your code. It helps with ensuring that your code is not too incorrect. And it's actually quite compatible with JavaScript. Never mind this syntactic sort of hack that is still years in the future. But any library that is written in pure JavaScript can still be used from TypeScript programs. And also the other way around. You can write a library in TypeScript and then export it in a form that is totally consumable by JavaScript. That sort of compatibility is sort of the key to the success of TypeScript.
Yeah, just to look at it as almost like a biological system that's evolving. It's fascinating to see JavaScript evolve the way it does.
Well, maybe we should consider that biological systems are just engineering systems too, right?
Yes.
Just very advanced with more history.
But it's almost like the most visceral in the JavaScript world, because there's just so much code written in JavaScript that for its history was messy. If you talk about bugs per line of code, I just feel like JavaScript eats the cake, or whatever the terminology is. It beats Python by a lot in terms of number of bugs, meaning like way more bugs in JavaScript. Mm-hmm. And then obviously the browsers are developing. I mean, just there's so much active development. It feels a lot more like evolution, where a bunch of stuff is born and dies, and there's experimentation and debates, versus Python is more, all that stuff is happening, but there's just a longer history of stable working giant software systems written in Python, versus JavaScript is just a giant, beautiful, I would say, mess of code.
It's very different culture, and to some extent differences in culture are random, but to some extent the differences have to do with the environment.
Yeah.
And the fact that JavaScript is primarily the language for developing web applications, especially the client side, and the fact that it's basically the only language for developing web applications makes that community sort of just have a different nature than the community of other languages.
Plus the graphical component, and the fact that they're deploying it on all kinds of shapes of screens and devices and all that kind of stuff. It just creates a beautiful chaos. Anyway, back to MyPi. So you talked about a syntax that could work. Where does it currently stand? What's the future of static typing in Python?
It is still controversial, but it is much more accepted than when MyPi and PEP 484 were young.
What's the connection between PEP 484 type hints and MyPi?
MyPi was the original static type checker. So MyPi quickly evolved from Yuka's own variant of Python to a static type checker for Python, and sort of PEP 484, that was like a very productive year where like many hundreds of messages were exchanged debating the merits of every aspect of that PEP. And so MyPi is a static type checker for Python. It is itself written in Python. Most additional static typing features that we introduced in the time since 3.6 were also prototyped through MyPi. MyPi being an open source project with a very small number of maintainers, was successful enough that people said this static type checking stuff for Python is actually worth an investment for our company.
Nice.
But somehow they chose not to support making MyPi faster, say, or adding new features to MyPi, but both Google and Facebook and later Microsoft developed their own static type checker. I think Facebook was one of the first. They decided that they wanted to use the same technology that they had successfully used for HHVM, because they had a bunch of compiler writers and sort of static type checking experts who had written the HHVM compiler, and it was a big success within the company. And they had done it in a certain way, sort of. They wrote a big, highly parallel application in an obscure language named OCaml, which is apparently mostly very good for writing static type checkers.
Interesting.
Yeah.
I have a lot of questions about how to write a static type checker then. That's very confusing.
Facebook wrote their version and they worked on it in secret for about a year, and then they came clean and went open source. Google, in the meantime, was developing something called PyType, which was mostly interesting because it, as you may have heard, they have one gigantic monorepo. So all the code is checked into a single repository. Facebook has a different approach. So Facebook developed Pyre, which was written in OCaml, which worked well with Facebook's development workflow. Google developed something they called PyType, which was actually itself written in Python. And it was meant to sort of fit well in their static type checking needs in Google's gigantic monorepo.
So Google was in one giant, got it. So just to clarify, this static type checker philosophically is a thing that's supposed to exist outside of the language itself. And it's just a workflow, like a debugger for the programmers.
It's a linter.
For people who don't know, a linter, maybe you can correct me, but it's a thing that runs through the code continuously, pre-processing to find issues based on style, documentation. I mean, there's all kinds of linters, right? It can check that. What usual things does a linter do? Maybe check that you haven't too many characters in a single line.
Linters often do static analysis where they try to point out things that are likely mistakes, but not incorrect according to the language specification. Like maybe you have a variable that you never use. For the compiler, that is valid. You might be planning to use it in a future version of the code, and the compiler might just optimize it out. But the compiler is not going to tell you, hey, you're never using this variable. A linter will tell you that variable is not used. Maybe there's a typo somewhere else where you meant to use it, but you accidentally used something else, or there are a number of sort of common scenarios. And a linter is often a big collection of little heuristics where, by looking at the combination of how your code is laid out, maybe how it's indented, maybe the comment structure, but also just things like definition of names, use of names, it'll tell you likely things that are wrong. And in some cases, linters are really style checkers. For Python, there are a number of linters that check things like, do you use the PEP8 recommended naming scheme for your functions and classes and variables? Mm-hmm. Because like classes start with an uppercase and the rest starts with a lowercase, and there's like differences there. And so the linter can tell you, hey, you have a class that whose first letter is not an uppercase letter, and I just find it annoying. If I wanted that to be an uppercase letter, I would have typed an uppercase letter, but other people find it very comforting that if the linter is no longer complaining about their code, that they have followed all the style rules.
Maybe it's a fast way for a new developer joining a team to learn the style rules, right?
Yeah, there's definitely that. But the best use of a linter is probably not so much to sort of enforce team uniformity, but to actually help developers catch bugs that the compilers, for whatever reason, don't catch. And there's lots of that in Python. And so, but a static type checker focuses on a particular aspect of the linting, which, I mean, MyPi doesn't care how you name your classes and variables. But it is meticulous about when you say that there was an integer here and you're passing a string there, it will tell you, hey, that string is not an integer. So something's wrong. Either you were incorrect when you said it was an integer, or you're incorrect when you're passing it a string.
If this is a race of static type checkers, is somebody winning? As you said, it's interesting that the companies didn't choose to invest in this centralized development of MyPi. Is there a future for MyPi? What do you see as will one of the companies win out and everybody uses like Pi type, whatever Google's is called?
Well, Microsoft is hoping that Microsoft's horse in that race, called PyWrite, is going to win.
PyWrite, right? Like RIGHT?
Correct. Yeah, all my word processors tend to typo correct that as pyrite, the name of the, I don't know what it is, some kind of semi-precious metal.
Oh, right. I love it. Okay. So, that's the Microsoft hope, but so let me ask the question a different way. Is there going to be ever a future where the static type checker gets integrated into the language?
Nobody is currently excited about doing any work towards that. That doesn't mean that 5 or 10 years from now, the situation isn't different. At the moment, all the static type checkers still evolve at a much higher speed than Python and its annotation syntax evolve. You get a new release of Python once a year. Those are the only times that you can introduce new annotation syntax. And there are always people who invent new annotation syntax that they're trying to push. And worse, once we've all agreed that we are going to put some new syntax in, we can never take it back. At least the sort of deprecating an existing feature takes many releases, because you have to assume that people started using it as soon as we announced it. Mm-hmm. And then you can't take it away from them right away. You have to start telling them, well, this will go away, but we're not going to tell you that it's an error yet. And then later it's going to be a warning. And then eventually 3 releases in the future, maybe we remove it. On the other hand, the typical static type checker still has a release like every month, every 2 months, certainly many times a year. Some type checkers also include a bunch of experimental ideas that aren't official standard Python syntax yet.
Yeah.
The static type checkers also just get better at discovering things that sort of are unspecified by the language, but that sort of could make sense. And so each static type checker actually has its sort of strong and weak points.
So it's cool. It's like a laboratory of experiments.
Yeah.
Microsoft, Google, and all, and you get to see.
And you see that everywhere, right? Because there's not one single JavaScript engine either. There is one in Chrome, there's one in Safari, there's one in Firefox.
But that said, you said there's not interest. I think there is a lot of interest in type hinting, right? In the PEP 484. Actually, like, how many people use that? Do you have a sense? How many people use, because it's optional, it's a sugar.
I can't put a number on it, but from the number of packages that do interesting things with it at runtime and the fact that there are like now 3 or 4 very mature type checkers that each have their segment of the market. And then there's PyCharm, which has a sort of more heuristic-based type checker that also supports the same syntax. My assumption is that many people developing Python software professionally for some kind of production situation are using a static type checker. Especially anybody who has a continuous integration cycle probably has one of the steps in their testing routine that happens for basically every commit is run a static type checker, and in most cases that will be MyPi. So I think it's a pretty popular topic.
According to this webpage, 20 to 30% of Python 3 code bases are using type hints.
Wow. Wonder how they measured that. Did they just scan all of GitHub?
Yeah, that's what it looks like.
Yeah.
They did a quick, not all of, but like a random sampling.